Okay, so guys, this week we're talking the ultimate showdown, right? Pepsi versus Coca-Cola. And I'm on a no sugar cleanse at the moment, so I've got the lights here. Mr. Hunselaar is going to be sipping on a normal Coke and a normal Pepsi throughout the episode. And by the end of the episode, I really want to get your feeling on a... We've had a bit of issues with the paper straws. Believe it or not, they don't do very well with carbonated drinks. I don't know. But anyway, he's going to tell us his final thoughts on if he's a Coke man or a Pepsi man. But or do you have preconceived feelings about this? Just so I know. Have you always been a Coke guy?
Generally, I've been generally I've been a Coke guy, but I've never minded a Pepsi.
Is it? Okay, so I want a definitive answer by the end of the episode, so keep sipping those down. Let us know. Believe it or not, this episode is not sponsored by either Pepsi or Coke.
Or anyone for that matter.
Or anyone for that matter. But if you really want to sponsor us some drinks, please reach out to us. That would be great. So this week, we are talking about, like I said, the ultimate showdown, Pepsi versus Coke, but in a broader sense, we're talking about the beverage industry. So... some cool facts. Let's start with where this all began, right? Carbonated drinks have not always been around. We've made things like beers, fermented fruit juices, stuff like that since ancient times. But the real first carbonated drinks, I've got some cool factoids for you here, Mr. Hunselaar. The first person to actually physically get carbonation into water was Mr. Joseph Priestley. And he did that in 1767. A young... was that 300 years ago? Almost?
Sure.
Almost that's 300 years ago, right? So he was the first guy to get some carbonation into drinks. And then the first popularized commercial soda water came out in 1783. And would you not believe that the oldest carbonated beverage company in the world, Schweppes.
Schweppes.
Yeah, when I saw their Schweppe, I was like,
I know that.
Call me the dry lemon Schweppes.
Right? Little dry lemon Schweppes. So Schweppes is actually the oldest carbonated drink company in the world. And by the early 1800s, peeps were sucking this stuff down, man. They were ready for it, and it was being sold commercially. This is the wildest part. Most carbonated beverage drinks of the day were sold in pharmacies because it was said to have certain health benefits. It was meant as a digestive.
Like just the carbon part, or because not the sugary part.
Whatever marketing went on, these were being marketed as good for your health, make you happy. A lot of them came out as syrup-based, commercially available drinks. So they were clearly not good for you sugar-wise, but clearly people bought it. And Coca-Cola Company was started in 1886. We had Dr. Pepper come out in 1885. Pepsi coming out firstly as Brad's drink, actually. Then, thank goodness they actually changed the name to Pepsi. 1893. Brad's drink.
I don't think that would have been very marketable. I can understand why they changed the name.
We only served to Brad. And then in 1876, we had Charles Hires. He was a Philadelphia pharmacist. He introduced commercially available root beer. And that was actually the first, other than something like a carbonated water, that was the first carbonated, fizzy, soft recreational drink. So root beer.
Dr. Pepper came before Coca-Cola.
Can you believe it, man?
Hey,
and Schweppes came before them all. Again, it was marketed as a carbonated beverage, which had very good medicinal benefits. And this is how they sold it. They sold it as a health food.
But even nowadays, I mean, there's the wives' tale. I don't know if it's true. Is it true? If you drink a flat Coke, then if you have an upset stomach, then apparently it settles it down.
We need to actually settle that probably, but my mom always used to tell me that. Tummy's upset, get a flat Coke.
Yeah.
100%. Always.
I'm not going to lie, I'm not really keen to settle that because I'm not keen for an upset stomach.
Even me, man. But anyway, so we get to how we got here today. In the 1900s, when Hollywood was coming up, they started to popularize soft drinks. Whatever happened behind the scenes to make that happen, who knows? But we saw things like in It's a Wonderful Life. That was 1946. Coca-Cola signs everywhere, right? And I've seen that in a lot of movies as well. Back to the Future has the famous scene where there's a Pepsi of the future. I can't remember what it was called. The Pepsi, you can see it on the picture, but I can't see it now. Pepsi Future, something like that. Where Marty McFly flies actually to 2015 to buy a Pepsi of the future.
You must have this special. Hey, guys, hey. All I want is a Pepsi.
You can really, from that picture, you can really see that they thought that the cap cups were going to
be the thing, right? And he flew to 2015. He got himself this Pepsi of the future, and he paid $50 for it. Now, believe it or not, Pepsi did actually release the special edition in 2015, but they didn't charge $50 a bottle for it. They charged $20.15. 2015. Do you like that? So yeah, that was cool. And then we had actually, this is interesting. I don't know if you've ever seen this, The Gods Must Be Crazy, a film that came out in the 1980s. It was a South African movie released by Ster-Kinekor. And literally the main plot point of this movie, it actually sounds wild, I think we need to watch it, is that a hunter-gatherer of like a Khoisan tribe picks up a glass bottle that fell from a plane. And basically they decide that this thing is now a gift from the gods. And this is like the whole point of the movie, is this glass Coke fell out of the plane and it was a gift from the gods. So I think we need to watch it. South African movie.
Gotta watch it.
You know, gotta watch it. So I think all of this to say that really soft drinks have become a part of the culture, right? We consume them. We're consuming them from plastic bottles, from cans, things like that. And this, last thing I'll put in this section, if you see that little picture there.
With the bebe.
These are actual adverts that would come out. Like how...
So that can't be good for... to be honest, like... the longer you look at it, the worse it gets.
The weirder it becomes, right? I'll throw this picture up as well. But it's literally a marketing campaign about how 7-Up, which is 7-Up or Sprite or however you want to put it, they have the youngest customers in the business because parents used to feed this to their kids. It's like a healthy thing. Like when you're like a year old.
I'm not going to lie. That advert did not age well.
Did not age well at all, right? So anyway, guys, if you are enjoying our content and you like the stuff we put out, we would really appreciate it if you guys would subscribe. If you would hit that subscribe button, hit that like button for the YouTube algorithm, we would really appreciate it.
And comment whether you prefer Coke or Pepsi.
Comment if you're a Pepsi guy or a Coke guy, which Mr. Hunselaar will give his input on right at the end. Right? How are you feeling at the moment? Or is it neck and neck?
I'm still
figuring it out. So apparently, just a quick note, apparently Pepsi usually wins on a one-sip basis, but on a whole can basis, Coke usually wins on flavor. So I'm interested to see. This is some real empirical evidence going in. So being an engineering and science podcast, I wanted to discuss, my main thing is to discuss the actual manufacturing of these beverages, because whatever you think about them, there's some cool technology that's gone into this, and a lot of it affects our daily lives. So as you guys would know, we either are buying these things in plastic bottles or we're buying them in aluminium cans. For the Americans, aluminum cans, right? And for those affluent of us, we buy them in glass bottles. But I don't get to do that very often.
Yeah.
You know?
That's for special occasions.
For special occasions. So the first thing is PET bottles. Polyethylene, something with a T. Tritrate, something like that. Anyway, not the main point of this point that I want to make.
Not the important part.
So the real interesting thing about this is these little bottles start as preforms, what are known as preforms. And they literally look like, it's like the top of the plastic bottle and then a test tube on the bottom. And that's how they get made. Usually they're made in a big factory that produces a lot of them. And then they get shipped all over the world because obviously Coke and Pepsi have factories all over the world. They make the bottles in country and then that's shipped to the end, to the ShopRite and the Checkers and stuff like that. So they make these little preforms from these little PET pellets. And the reason they do that is because it's cheap. It's much cheaper to transport a little test tube size thing than to form the entire bottle and then ship it off to them.
And I think it makes sense. And also, if you're the one that's making the little test tube bottle things, then you can sell it to all the different companies.
And it's a standard thing.
Yeah, it's a standard thing. And then like any bottle form could be produced.
You basically, as long as you have the machine, you can make it in country where you need to. And this is so successful, in fact, that Coca-Cola produces about 110 billion plastic bottles every year. That's only Coke. It's not even Pepsi. I couldn't find Pepsi stuff, but that's crazy. I would assume it's comparable. So we're talking about 200 billion plastic bottles in the world.
Sure.
And the reason this is important and cool is that this would never be possible if we didn't have global supply chains. And one of the important ones is we need suppliers who make the little PET pellets. So usually that's created from crude oil, and then they refine that off to get the PET. And because that's so available, factories in China and all around the world can create these little preforms and then ship them all over the world, and we can all enjoy a nice, crispy, fresh Coke from a plastic bottle. You're doing all right.
It's a lot of gas.
So the next one I want to talk about is aluminium cans. Now, this was interesting, and we will link to a very cool video made also by an engineer, where basically he explains the whole can forming process. And what a wholesome video, man.
Yeah, right? No, it was good. I think when I watched it, my favorite comment was, it's a conversation, YouTube. Do you want to watch a 12-minute video of a guy talking about aluminium cans? And it's like, you're goddamn right.
So yeah, aluminium cans also a large part of the market. And these cans, start off as a little disc of aluminium. And again, this is all made possible because we have huge mining facilities, huge facilities to refine aluminium and create these little discs. And then these little discs are shipped all over the world to the countries where they will be sold, and they're formed in those countries. Now, Mr. Hunselaar, I'm going to sort of lead you down the path just to make this a bit more interesting. How thick would you say the thickness of a can ends up being right at the end of forming?
I would say like not even half a millimeter.
Not even half a millimeter. You're actually close. So it actually ends up being thinner than the average diameter of a hair, which is about 70 microns. Right? So very, very cool how much they get to stretch this thing. Then if we go from, why do you think there's a dome in the bottom of a can?
I'm going to go with force distribution.
Force distribution, right? So for anyone, I can't actually, let me get a full can.
Yeah.
So there's always a dome placed in the bottom of the can, and obviously manufacturers won't do things that don't make sense for them because it costs money to put that little dome in. And again, yes, it's to distribute force on the bottom of the can so it doesn't buckle during transport or storage or when temperatures and stuff go up and down. Next one, is there or is there not a protective coating on the inside of an aluminium can once it is done forming?
I do know that there is a coating on the inside of it.
Yes. And do you know why that coating's there?
I'm assuming because the carbon, it's carbonic acid basically. When you dissolve carbon dioxide in a
into a
liquid,
fluid, yeah.
and then that would eat away at the metal, so they have to put the
Exactly.
film there so that it can protect
Exactly that.
the aluminum.
So right before the top aluminium cap that has the little latch on it goes on, they do spray a little plastic epoxy coating on the inside, a little in there. And it, again, because there are corrosive acids inside these drinks, it's to protect the inside of the can, so you get longer shelf life ultimately. So that's very cool. The other thing is, so they form the entirety of the can up to the top neck, up to the lip, and then they form the lip in 11 different stages. Now, honestly, guys, go watch the video that this guy does. It was really awesome to see the can and how it changes over these 11
and you
stages.
will understand.
You will understand it, and you will watch it multiple times. So we love that. Then a very interesting technology on the aluminium cans is this little lip, which we've never really paid attention to in real life, right? So the little lip on the outside of the cap here is actually a very cool piece of technology. It is formed using what's known as a double lip technique, where they basically fold the underneath and then a piece over it to clip in place, and they have a little sealing compound there as well. But this prevents them from having to weld the can shut, which is what they would have to do with steel cans back in the day when these cans were first being made. So very interesting little piece of technology.
And I'm assuming it also saves time.
Saves time, saves effort, saves manpower, which is really, really cool. Then, Mr. Hunselaar, do you know what the maximum pressure, I know you know this so you can answer, what's the maximum pressure these little cans can withstand, internal pressure?
4 bar. No, it's 6 bar.
It's up to 6 bar, right? So the actual fluid inside here is pressurized to 2 bars of pressure just to keep it nice and fizzy and to keep the integrity of the can intact because, as you can see, squeezing on that one, pretty strong. And then we move to these, pretty easy to drop as well. But as you can see, we got a bit of flex there. On a can that's full, you won't. And that's because of the internal pressures, right? So very, very cool. And just ending off on this, cans are produced at a massive speed. Most bottling plants are producing 2,000 plus cans per minute in the countries.
Sure, that's wild.
It's a ridiculous amount. And if we had to think about that, we estimated these cans to be about 200 mils tall, okay? That would be enough cans to go up high, stacked on top of each other, 400 meters high. And to give more context, if you had to take the Eiffel Tower, then you take 17 fairly large, very on the upper end of average elephants on top of each other, and then stack one baby elephant on top of that. That's how many cans are produced every single minute in respective bottling plants, which is really cool.
That's wild,
right?
Man. What a time to be alive.
Crazy. And here's the interesting one for you. So Coca-Cola estimates that they get globally about 1.9 billion servings of their products each and every day. So that's across Coke and Fanta and all of those products, but 1.9 billion servings, man. That's crazy. That's a crazy amount of cans and bottles to have to keep up with.
And also, let's just face it, Coca-Cola's marketing.
Incredible.
Like, honestly, to be
in that meeting.
To be like one of the drinks that like it's a go-to beverage.
Literally. Yeah. So again, what makes this all possible? Global supply chains, having access to large quantities of the plastic and the aluminium that we need. Another big part of it is we have access to a lot of carbon dioxide. often produced from industrial processes, which we then refine down to be a food-grade carbon dioxide. And that's all possible because we have large industries and large supply chains to make this possible. And again, we move into the filling lines just to give you guys a brief understanding of how quick these filling lines actually work. So these are the actual machines that put the Coke or the Pepsi in these bottles, in these cans. Some of these high-speed filling lines are doing 120,000 bottles, so PET bottles an hour, okay? And that's a ridiculous amount of fluid to dispense accurately, safely, and in a sterile way, which is very, very difficult, actually, if you have to think about it.
It's actually very cool, man.
It's actually very cool, right?
When you think about it.
A lot of this revolves around hygiene. Like, we have very strict hygiene standards, and a lot of that is made possible because we have such clean facilities. And they also use what's known, it's a methodology known as clean in place. So oftentimes it's usually time-based, every 4 hours, 8 hours, every shift. They will have machines that basically stop the production line, and they clean themselves in place to make sure that the next run they do is also clean.
Well, that sounds awesome.
And isn't that magical, right? So that we don't get sick as consumers.
Just imagine a conveyor belt giving itself a little bubble bath.
Giving itself a little bubble bath. All right, guys, so as we come to the end of this, I thought it would just be interesting, like, how does a bottling plant know whether it's being successful, whether it's being good, bad, average? So here's a little KPIs that these guys are measuring. I'm also feeling a burp come up here.
Yeah, I know.
Oh, goodness. Yeah, that medical grade CO2 really,
It really gets you, eh?
it really gets to you. So just to put into perspective how much it costs if a plant goes down, so a bottling plant goes down, these are just estimates, obviously, and it depends on the size of the plant. But if we say that a beverage filling line can produce 2,000 bottles a minute, and let's say we're down for 30 minutes, for whatever reason, someone didn't grease a bearing or a chain broke or whatever the story is, right? And you're able to fix it in 30 minutes, that's about 60,000 units lost. And if we estimate it's about $50 per thing of revenue, that's a loss of $30,000 in revenue. So these costs add up very quickly, and I'm sure that's a very conservative cost, actually.
Yeah.
But anyway, some KPIs that engineers in these plants are often tracking is what's known as the overall equipment effectiveness. Now, for the nerds out there, this is basically availability, so how much the machine is available, times the performance of the machine, so what speed is it working at, and then what's the quality of the final product. And that would just be how many units are defective versus how many are actually can be sold. Okay,
Makes
and that's how
sense.
they track their effectiveness. A score of 85% on that metric is good, is basically world class. Anything under 60 or 70%, you're doing all right.
So
man.
it's the gas.
Often management will get involved to change out staff or whatever.
So I know.
You don't want to include the burp in the in the body, man.
Maybe, but sure.
Maybe, but not for you. Okay, so that's the one. They use overall equipment effectiveness. The other one is yield, obviously. You want to know how much you're producing. So modern plants, you're often achieving a 95% yield. So these are things that are without defect, okay?
95% yield.
95% yield.
And didn't you say 85 is the world standard, or what's
That's overall equipment effectiveness. So that's those three parameters times together, okay? Yield is a different thing. So basically, on average, it's assumed that between 2% and 4% of beverage production goes to waste. We had this the other day, actually, where one of our salespeople went to a beverage plant, and if they wrap a pallet and they figure out that one of the actual things was defective in that pallet, it's not worth for them to unwrap the pallet and take the one out. They discard the whole pallet.
That's wild.
Right. Wild, right? And that stuff must be recycled by law. You're not allowed to just throw Coke down the drain. So they send it to a recycling plant, but it goes to waste, 2 to 4% of that yield. Then we have another interesting one, because we like the environment here, and it's cool. We have what's known as the water intensity ratio. So this is that basic thing, like how much water does it take to produce 1 liter of Coke or 1 liter of Pepsi? And the global average is somewhere between 1.7 and 2.5 liters. So if you're making 1 liter of Coke, you're using 1.7 liters to make it. Okay. And because that involves the whole process. It involves the washing of the bottles and the washing of the machines and obviously the fluid that goes into the bottle. So it's a pretty water intensive thing to go through.
Yeah, I mean, you're drinking it, so of course there's going to be lots of water involved.
Exactly. But so there is a silver lining to this. There is a drive from Coke and Pepsi themselves to drive that ratio down actually to 1.2.
Okay.
So that means for every 1 liter of Coke you're producing, you're using 1.2 liters of water to produce it. So that means 200 mils is going to cleaning and stuff like that. And that's just getting more efficient. Okay.
Yeah.
So that, guys, is in summary the beverage industry. That's the Pepsi versus Coke episode. I want to sum this up. Mr. Hunselaar, you've been drinking those Pepsis and Cokes for this episode. How are we feeling here? What's the final verdict?
I can definitely understand why people say Coca-Cola is the better full drink. Because I mean, look, maybe I'm just getting too much sugar in my system. Because like let's just be honest. Like over time, both of these are tasting worse and worse with every
Oh,
sip.
really? Just too much sugar?
Yeah, just too much
Got
sugar in this short amount of time.
Got you.
But right now, the Coke is tasting nicer than the Pepsi.
Oh, my word. So are you a Coke man?
Yeah, I
You were a
guess-
Coke man coming into this.
Yeah, look, I'm not going to say there's no bias.
Okay,
but
got you.
Yeah,
Got
I think
you.
I'm going to stick with
You're going to
Coke.
stick with Coke, man. I've decided I'm a Pepsi man. So I was really hoping to turn you on this episode. But clearly I haven't succeeded. But there we go, guys. 1.9 billion servings of Coke every day. And it's proved why that is the case. Because Mr. Hunselaar is a Coke man. So, Mr. Hunselaar, let's end off on recommendations. You got a recommendation for us this week?
Not this week. I've recently finished Modern Family.
And? Would you watch again?
I would watch it again, but maybe in the background. I wouldn't make a seating of it.
Is it?
But it's good humor, good writing. I enjoyed it. It was nice while it lasted. But I'm not really watching anything now. I'm not excited to go home and watch a specific series anymore.
Oh, no, man. Come on, dude.
I'll get there, don't
You got
worry.
to go back through our episodes and look at the recommendations and
Yeah.
stuff. Well, now we have that weird South African one, man. What? The Gods Must Be Crazy. So you got to watch that this weekend. From me, I watched Den of Thieves. It's a movie. It's a two movie. I think there's going to be a third one. But basically, bank robbery, heist. In the first one, they rob the Fed. In the second one, they rob the diamond exchange. Pretty good, I must say. For those who like a little bit of bank robbery and all of that stuff, really cool. Enjoyed it a lot.
All right, lekker, man.
All right. Thank you guys so much for listening. We will catch you in the next one.